How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for development of the periodic table and effective nuclear charge. All right, so number one, which set of elements would you expect that all of the elements would have similar chemical properties? So the key here is seeing that went too far. Similar chemical properties means that they're in the same group. So remember that groups run vertically. So which one of these sets of elements are in the same group? Well, let's check A. We got oxygen, sulfur, and selenium. Hey, that looks like that might be our answer, but let's check the rest of them. We got nitrogen, oxygen, and fluorine. They're in the same period. They're not in the same group. We got sodium, potassium, and magnesium. Nope, that's not going to be it. Phosphorus, sulfur, and chlorine. Not quite. They're in the same period, not the same group. Then we got helium, neon, and fluorine, which is almost, but not quite. So best answer, definitely choice A. All right, question number two. Who is credited with developing the idea of atomic numbers? So this is a factual question. There's no real processing to it. This is just, you know that Henry Moseley is the one that came up with atomic numbers, figured out their thing. All right. So elements in the modern periodic table of elements are arranged in order of increasing atomic number. All right. So the periodic table has all these patterns that repeat periodically when you have them listed by atomic number. When you did atomic mass, then you would get almost the right setup, but there's a couple of errors in that. So modern periodic table, atomic number. Why are the electrons in the 1s subshell of argon closer to the nucleus than the electrons in the 1s subshell of helium? Well, it comes down to the effective nuclear charge. So if I'm taking a look at argon, its nucleus has how many electrons? It's got 18. So it's got a positive 18 charge. So those electrons in that first energy level are going to be really attracted to that plus 18 because they're negatively charged. Nucleus is positively charged. They're going to be held a lot closer or tighter. Whereas helium only has a plus 2 charge, so those electrons aren't nearly as attracted to that nucleus. So there you go. So the keyword sometimes might be looking for effective nuclear charge. In this case, argon has a much greater effective nuclear charge than helium. All right, the effective nuclear charge of an atom is mainly affected by shielding. Shielding electrons. So if we're taking a look at just any old atom, and we have electrons in the first energy level, and then we got electrons in the second energy level, we know that the nucleus is positive, and this electron is going to be pulled towards that nucleus. There's no shielding, but this electron right here is going to be repelled by the inner electrons that are in between it and the nucleus. So it's not going to feel as strong of a nuclear charge than this electron because there's electrons in the way repelling it. All right, number 6, in a many electron atom, an electron in which subshell will experience the greatest effective nuclear charge? So this one, we're looking for the one that has the least amount of shielding. So which one is closer to the nucleus? All right, so looking at this, we got 2p. 3p is not as close as 2p. 4p is not as close as 2p. Now there's 4s. Now there's 3d. So option A. I always second guess myself when the right answer is the first one. All right, 7. Electrons in which subshell of tin will experience the lowest effective nuclear charge? So this is talking about the greatest amount of shielding. So which one of these is the furthest away? Which one has the most electrons in the way? Let's see, 1s is the closest, so I know it's definitely not going to be that. All right, 2p. Well, 3d is further away than 2p. 4s is going to be further. Oh, look at this, 5p. The furthest away option is 5p. Highest energy level, p sublevel. And is that it for all those questions? That's it. Hope you found it helpful. I'll see you in class. Okay, bye.